So we want to adopt. Today we will see Unit 5, What and Forest of Free Method. First topic is introduction about the PCA. That's the concept of analysis. What is differential quantitative analysis? Differential quantitative analysis is a method of dimensionality reduction, feature extraction that transform the data from three-dimensional space into a new coordinate system of dimension p, where p less than or equal to t. So the full component analysis clearly state that it is a dimensionality reduction. So from after dimensionality reduction, we can extract the features from the input data. Also, it transforms the data from one form to another form, from d-dimensional space into the p-dimensional space. P obviously less than or equal to d because reduced data set. We are giving some data set. Let's take d-dimensional data. But after applying PCA, virtual component analysis, the d-dimensional data reduced to p-dimensional data, p always less than or equal to d. After that, from p we can extract the features. After extraction of exact features, the dimension of the data is reduced. That is what the virtual component analysis. The PCA was invented in 1901 by Thomas Pearson as knowledge of principal axiom theorem in mechanics. Yes. It was later independently developed and named by Harold Hotelling in 1930. What are the goals of PCA? The main goal of PCA is to analyze the pattern, important patterns in the data. So before understanding the object focus and object network, we must understand the PCA. That's what we are saying this PCA, some of the PCA. PCA, the main goal of the PCA is to identify the patterns, and extract the features from the data. And also it is the dimensional reduction. It is basically used to reduce the dimension of the data set. Already you have a data set. From the data set, the PCA extract the important features and it reduces the dimension of data set from one dimension to another dimension. The second dimension obviously lesser than the first dimension. Understood? PCA aims to detect the correlation between the variables. PCA, which will commonly aims to detect the correlation. What is the correlation between the data, between the variables? That's the main goals. These three goals achieved by the PCA. First one is identifying pattern. Second one is reduce the dimensional dimension. Third one is detect the correlation between the variables. Good. Then transformation. What is the transformation technique? In order to approximate the space spanned by the original dataset, for example, original dataset x equal to xi, I equal to 1 to n. We can choose p based on what percentage of variance of original data we would like to maintain. We have to choose second dimension p based on the what percentage of variance of original data we would like to maintain. Based on that, we have to choose. The first principal component has the maximum variance, thus it accounts for the most significant variance in data. The second principal component has second highest variance and so on until the principal component has minimum variance. So every time the principal component analysis, extracting the features and reducing the dimensionality and identifying the patterns. The first principal component has the maximum variance. The second principal component has second highest variance. It goes until the principal component has minimum variance. That's what the ultimate aim of the PCA. This is the transformation procedure. Then, what are the approaches of PCA? PCA standardized the data. It is extracting the feature and it reduces the dimension in order to standardize the data and perform singular vector decomposition to get eigenvector and eigenvalues. It performs the singular vector decomposition to get the eigenvector and eigenvalues from the data. Short eigenvalue is descending order and choose the k eigenvector and also construct the projection vector from the selected k eigenvector. Transform the original dataset via projection matrix to obtain the k-dimensional features subspace. Already you know eigenvector procedure. It is transforming the original dataset via projection matrix to obtain a k-dimensional feature subspace. So one dimension to another dimension with the help of k eigenvectors. So these are the this is the sample example how the dimension is reduced or how the data features are extracted from the original data set. So figure 1, we have a data set and after applying PCA reduction of BCA data set and it is plotted in the graph. And also 2D plot is shown here and 3D plots also shown in diagram so that we can easily understand the feature extraction from the data given. So the principal component analysis, extracting the features and also reduce the dimension and also extracting the patterns. Okay, so that we can understand what kind of data it is. Okay, so that is what the major goal of PCA. Before understanding the autoencoder, we must understand PCA because autoencoders also they are using they are extracting the features or reconstructing the data, everything they are doing autoencoders. But before understanding the autoencoder, we must understand what is PCA. It's a simpler version of autoencoder, we can say. From that, we can understand how we are transforming PCA to autoencoder. So earlier days we used PCA, nowadays we are using autoencoders. That is what the main with this class. So you must understand what is PCA now. Okay. So that's all about PCA. Now we recall the information now. So first, what is PCA? Principal component analysis, a method of dimensionality injection, also feature extraction. And also this transforming one data dimension to another data dimension. The second dimension obviously lesser than or equal to the first dimension. Okay. Principal component analysis time definition. And it was invented by Carl Pearson at 1901 itself. But the theorem in mechanics he developed. But later Harold Kotelling in 1930, he independently developed and named this PCA. Okay. Then major goal of PCA is to analyze the pattern, the data set, and reduce the dimensionality in the data set and aims to predict the correlation between the variables. This is very important because, for example, we have a different kind of data variables and we have to analyze the relationship between these two variables so that we can reduce the data, whether it is needed or not needed. That we have calculate. That is done by the PCA. Okay. Whatever may be the case, like movie recommendation or cancer image analysis, whatever the field. So we should apply some feature extraction technique so that we can understand the what happens in the future. This is the one of the technique PCA, principal component analysis. It has 3 goals: identifying pattern, reducing the dimension, and detect the correlation between the variables. Yes. Then transformation. What's the transformation? It is transforming one dimension to another dimension. It uses x as a data set, xi, I equal to 1 to n dimension. Then it is transforming dimension D into dimension B. P is always less than the D. We have to extract the features and what percentage of variance of original data we would like to maintain, that we have to decide, and then we choose the P. The first component has the maximum variance, the second component has the second highest variance, and so on until the PCA has minimum variance. This is for the transformation. Then PCA approach is mainly for standardized the data, and it performs the singular vector decomposition, and it uses eigenvector and eigenvalues uh, to construct the projection matrix from the selected K eigenvector and transform the original dataset by a projection matrix to obtain the K dimensional feature subspace. So these are the various PC approach, and one example how the dimensionality reduction and feature extraction is done in BCA dataset after applying PCA. This is the example plot. We can see the entire PCA process and plot of 2D and plot of 3D also. You can see here. That's all about PCA. Thank you. Next class we'll see how to encode us. Thank you, Ananda.